Okay, next up we have Marco Morazan, who will be talking about making a hard topic, distributed programming, accessible to a hard audience, first-year students.
Well, I hope I don't disappoint you. I won't be talking about ... Okay, okay, so I'm going to talk about what we do at Seton Hall to introduce freshmen to distributed programming. And the goal of our course, of course, is to give them a solid foundation in programming and to get students excited about computer science. And so why distributed programming? Well, we can't deny it's becoming pervasive. And so I feel that we should be exposing our students to current trends. Okay? The other thing is that this is something easy to do. It's easy to get students thinking about them. So the goal here is not to make them experts in distributed programming, but just to get them started, to get their fingers dirty. Okay, so how do we do this? We use multiplayer video games, and we think of a distributed program as a refinement of a non-distributed program. So the idea here is that students have developed some code, and we're going to take that code now and run it in a distributed environment. The goal, of course, is we want to have a gentle introduction, but non-trivial, right? Something that will challenge students, but not overwhelm them. Okay, so students, before we start distributed programming, have developed a game that looks like that, Space Invaders-like game. And this uses all the HDDP stuff, right? Structural recursion and higher order functions abstraction. Okay, and so you ask students what's next, what do they want to do next? And of course, they want to have a multiplayer game. So we describe a distributed application as a set of components that cooperate with each other through a server. Right? And the question I pose to students is, how do we refine aliens attack? And so one answer, and this is where I had started with this, is have the server control the state of the aliens, the state of the shots. And then every other component is just a rocket, which represents a player that is moving that rocket and shooting. Turns out that didn't work out too well. Students didn't like that subdivision of tasks. They found it difficult, they found it unnatural, and it required a lot of code dissection, something that first-year students just seem to find overwhelming. So I said, well, let me ask the students what they would like to do. How do they envision it? And semester over semester, the answer came out like this. Let every component be its own, be a world which each player, right, act responsible for everything that a single-player game does, right? Rendering, moving the rocket, and then the server simply communicates actions taken by the players to all the other worlds. And that model, even though I am aware it's offensive to some of us who understand something about distributed programming, is a model that works for the students. It's simple.
Why is that offensive?
Well, because it sidetracks a lot of, we already know that there's going to be lots of bugs when we take this approach, right? In the simplest way, in the simplest form. Okay, so our focus, given that picture, is on symmetric distributed computing. Why symmetric? Because we'll have all the components run the same code, evaluate the same code, which means that there's less editing necessary by the students. So they can recycle their code easily, okay? As opposed to having the server maintain the state. So we still have to design and implement a server. We still have to design a communication protocol. And we have to design marshalling and unmarshalling functions. All of these are things that students will see in future courses or professionally. Okay, so how do we do it? You need a design recipe, and this is the design recipe we propose. We break up the program into components. We draft new data definitions in order to introduce components. Then we design a communication protocol. Sometimes you need to update your data definitions based on a communication protocol. Then you design marshalling and unmarshalling functions based on your communication protocol. Then you design and implement each component using, right, the functions and the data definitions that you've defined before. Then you implement a server, and finally, we test our program. Okay, so the breaking up of the program, I already told you, right? Each player is a component. and to draft new data definitions, right? What changes in the world? Well, now we have these interesting looking yellow ships, right? These are your allies. So the world changes, the data definition for a world changes, and that's what students need to develop, right? And we guide them through that, right? So a world without allies now becomes a world that has allies in it, right? And we need a definition for what the allies are, and all of this, again, reinforces everything about structural recursion that the students have gone through. Now we design a communication protocol, and for this we use protocol images and designs. So I'll show you in a second. So we ask the students, when should a player send a message to the server? And the answer is simple, right? When the player shoots or when the player moves the rocket. In other words, whenever there's a key event, right, that changes the state of the game, send a message to the server. Okay, so for example, if the player moves the rocket, certain things have to happen, right? World Sabai that moves the rocket sends a message to the server, and the server has to send a message to all the other worlds that this ally has moved, all right, with the position of the rocket. If a player shoots, again, very similar. You send a message to the server saying, I shot, and that shot has to, whoops, sorry about that. And that shot needs to be communicated to all the other worlds. Right? There's nothing here that a first-year student can't understand. It's a simple protocol. Then we ask them, when should the server send messages out? Right? And this happens in 3 different forms. Right? When the world joins the universe, that means that all the players have a new ally. When a world detaches from the universe, drops off from the universe, right? Everybody has one less ally, or when a message is received from the world. Okay, so for example, if a player or world joins an empty universe, that means that this is the first player in the game, and the server is responsible for sending the initial alien army. Now, what if they don't join a non-empty universe? In this case, the server has to request the state of the game from one of the worlds that is already in the universe and communicate to all the other, like before, communicate to all the other worlds that exist in the universe that they have a new ally. Once the world for whom the state of the game was requested gets to the server sends that back to the joining world. Okay, so based on this protocol now that the students have come up with, we have to design our marshalling and unmarshalling functions to actually be able to send messages. Right, so an example, if World Sabai shoots, then what we're going to do, right, is we need to marshal that shot as a list. It has a tag that says new shot and the X and the Y of the shot. And then, of course, if you're going to marshal, you need to unmarshal. Right? So to unmarshal a shot, we simply create a posin with the X and the Y that has been received in the message. Right? And if you do this for all the protocol diagrams that you have, in this game, we'll have 7 different types of messages, which leads us to a function template for functions on messages, which is something that the students will be able to use to implement their server and their components. Okay, so now we implement the components. The first step, we update for the new data definitions. Right? This is tedious, but it's easy. Right? Students know how to do this. Then we have to add our communication function, our communication code to all our functions that take actions that need to be communicated. And that, again, turns out to be extremely simple for students to do, given this protocol that we've designed that comes natural to them. Right? The only thing they do, instead of just creating a new world, they now create a package. And what? They have to marshal, for example, if this is a new shot, they have to marshal that shot and send it over to the server. Again, it's one line of code that changes, something that students can handle. And then the last step in refining the single thread program is to design and implement a message processing function. And for that, we use the function template on messages that we developed as part of our protocol design. And so, for example, if the message is a rocket move message, what do we do? Well, we know that one of the allies has changed, so we unmarshal our rocket move message and then call a function to update the allies. All this is based on structural recursion. Again, a topic that the students can handle. Okay, that's similar. And then finally, the sixth step, we have to design and implement a server. The first step is to come up with our data definitions that the server needs. So in this case, the server needs to know what the universe is, right? It's a simple list of iWorlds. And it also needs the data definitions for the alien and for a list of aliens. Why? Because the server is responsible for sending out the initial army to the first world that joins up. Okay, now we have to define our handlers for the universe. And in this case, we have 3 handlers, right? What happens when you add a new world? What happens when you get a message? What happens when the world disconnects? These make sense to the students, and we use our protocol design again to to implement these. So for example, what happens when a new world joins? Well, according to our protocol up here, right, when a new world joins, right, the server is made aware of that, and so what does the server have to do? It has to create a new universe that includes that world that has just joined. Then according to our protocol diagram, right, some messages have to be sent to the other worlds, assuming that the universe is not empty. So we send out a new ally message to all the other worlds. And in addition, although it's not clear up here, we have to request the world from some other world that's already in the game. Right? So we pick to just query the first world in our game. And then if the universe is empty when a world joins, then the only thing you have to do is marshal the initial alien army and send it to the world that joined. And then finally, we test our program, and this is where the course, right, can get really interesting for students, because now they discover a whole bunch of problems that can come up that are not faced by programmers that don't operate in a distributed setting. Right, so the idea here is that we have bugs in our program by design, because I want the students to discover these problems on their own. I want them to experience them. In other words, I don't want to come from the point that, hey, I'm experienced, I'm going to tell you what to do. Let them run with their instincts and let them find these issues, right? And then you can have great projects to solve one or more of these issues. So for example, the worlds can be out of sync, right? Right? It takes time to send messages across the network. So if the network is slow, right, by the time a shot reaches a world, it's out of sync with the originating world. If that shot hits an alien, maybe in the other world it doesn't hit the alien. Right? Another problem that we expose students to is there could be malicious worlds out there, right, that render the game useless, and etc. Right? So possible solutions, right? Communicate hits, or make the server keep the state of the aliens in the shots, etc. Right? And students usually come up with solutions that they do like to explore, and I let them run with it, right? If they make some sense, right? If they have some logic. Okay, so before I take questions, I have a plug. If you're working with education and using functional programming, I would encourage you to submit to TFPI 213, which will be with TFP this year out at BYU. Questions?